Have you ever wondered why the mercury within a thermometer doesn't stick to the sides? Or how the brake fluid in your car works? This is Speedy Science, looking at surface tension and viscosity. Surface tension, by definition, is the tendency of the surface of a liquid to resist and/or endure external forces such as gravity. To test this, we'll need a small glass, enough water to fill said glass, and at least 25-cent pieces. Some optional equipment includes a tray or plate, some food colouring, and a measuring jug or cup. If desired, mix water with food colouring and place glass on tray before beginning the experiment. Pour the water into the glass right to the brim. Once the waters stop shaking, slowly add in a 5-cent piece, one at a time, vertically in the centre of the glass. This is to be continued until the water spills.
Test experiment 3 times for reliability purposes.
The results of the experiment are as shown. From the image above, we can see that a small dome shape has formed above the glass. After testing the water, we also did 2 separate experiments using Coke and chocolate sauce to find the same thing happened. Water molecules stay close together through hydrogen bonding. The oxygen has a partial negative charge and the hydrogen a partial positive. These polarities attract each other and is known as cohesion. The molecules pull on each other equally in all directions and in doing so cancel each other out. But because the surface layer only has air molecules above, the cohesive bonds are much stronger than those in the glass. This makes an inward force that pulls the molecules towards the centre of the glass, keeping the molecules together. This in turn creates an almost elastic force of which contracts and resists being stretched or pulled away. This is known as surface tension. By definition, viscosity is the rate in which similar molecules in a liquid will flow past each other. To test this, we will need 2 baking trays, one shallow and one deep, a piece of paper large enough to cover the flat part of your tray, cling film, scissors, a ruler, a pen, and 10 ml of water, Coke, and chocolate sauce. Trace the bottom of your thin tray and cut it out. Rule 30 centimeters down the page vertically, drawing a horizontal line at that point. Then stick the paper to the tray with a cling wrap and sticky tape. Once completed, place thin tray inside of the deeper tray vertically. Pour liquid down the tray, making sure to time until the liquid reaches the line.
Test experiment 3 times for reliability purposes.
Cohesive forces in a liquid are strong enough to keep the molecules close but can still slide past each other. A fluid with a high or strong cohesive force will have a high viscosity. Liquids with a high viscosity have a low or slow flow rate. Liquids with a low viscosity will have a fast flow rate. If a liquid with a slow flow rate is heated, it can quicken the flow rate as molecules spread further apart when heated. Molecule size can also affect the flow rate. The larger the molecule, the harder it is for molecules to slide past each other, thus heightening viscosity and slowing flow rate.
So from what we've learned, what can we say about the thermometer and the brake fluid? So why does the mercury not stick to the sides? The force of cohesion of atoms, surface tension, is greater than the force of adhesion to the glass. This means that the mercury wants to stick to itself rather than the glass. The brake fluid in your car is affected by the viscosity as if the liquid was too thick, it would get stuck, not reaching the pedal in time to stop the car. If it was too thin, it would leak from the pipe. Different brake fluid viscosities can be matched to specific cars and affect the wear rates of the seals of the car.